We have looked at the side-side-side condition in Euclidean, hyperbolic, and spherical geometry. Now let's take a look in taxicab geometry. So the app works very similar to the others. You just pick 3 side lengths here, and we go out a distance of, take our taxicab compass and go out a distance of, in this case, 5. It could be anywhere on this taxicab circle. And then we go out a distance of 4 from A there, and a distance of 3 from B, and we see where these two circles meet, and this gives us 2 possible triangles. Now we know that they have sides. The red sides both have length 3, the green sides both have length 4, and of course the blue side is the same side, it has length 5. Are the triangles congruent? And in fact, notice that in fact they are not. Look at this. See those 2 angles? They're not the same. So that's a Euclidean reflection here over the blue line, but it's not a congruent triangle. Different ones. Furthermore, if I just take B and move it, I'm not only get just those 2 congruence classes, I get actually infinitely many different possibilities here. See, notice those even though the line segments are staying the same length as taxicab objects, those angles are just changing all over the place. And so we do not get just one congruence class, we get infinitely many. Now the triangle inequality still works. If these add up to the same as the other side, then in fact these triangles, these will not well, actually, that's not true. Actually, there are some triangles that are possible here. By going to the C2 here, we could actually get some triangles that are possible. So the triangle inequality actually is not necessarily true here. We can get this to work out where things work out. There are some cases, though, where you can get this long enough to where those circles will not meet. So in the case where they equal, there are some possibilities where the 2 sum to the same. But if you get a strictly greater than distance, then those 2, I believe, will not meet no matter where we go around. So there's still the triangle inequality, but a slight different version of this triangle inequality. We need the sum of the distances of the 2 smaller to be not just strictly greater, but greater than or equal to that other side. But once again, we see that the taxicab geometry is very different than the other geometries when it comes to triangle congruence, that oftentimes we can get infinitely many different congruence classes of triangles formed. So there's either 0 or infinitely many congruence classes. SSS condition is not enough to make the triangles congruent in taxicab geometry.